My attentions lately have been turning towards radio, specifically amateur radio. I've been studying for the foundation license. I've passed the exam. I'm just waiting for the paperwork to be processed now. Should be in about a week. Now, as a foundation licensee, I will not be able to build my own equipment. That's not permitted to foundation, because if you mess up, then you can jam radio over quite a range. That comes when I have an intermediate license. But I'm still going to learn the theory, and as practice, I've built this. It's here is my simulated radio link. It's an attenuator and a BNC connector that's not done up properly, so I get a very weak signal through. There's my transmitter, there's my receiver. There's no power amp on the transmitter. Right, now here's what the thing does. Amateur radio data modes, by and large, suck. They just do. The reason for this is that, with very few exceptions, data on amateur radio is transmitted using audio equipment. That is a radio designed for audio. You will have your computer. It will output a signal through the sound card. It goes into the microphone input on the radio, and at the other end the speaker output from the radio is plugged into another sound card, and that does the demodulation. This approach is not very good. It's just difficult. I can't explain the maths of it, but suffice to say it results in rather poor data rates, and you've also got to keep to a very narrow channel. Well, I didn't particularly like this constraint, so I thought, why don't I apply my knowledge of more modern networking and come up with something better? And I have. This here is 2/3 of a radio modem, transmitter only. All it's missing is the power amplifier on the output. It uses an Arduino and an analog devices synthesis chip. This will produce up to 30 megahertz. It'll actually go a lot higher than that, but beyond 30 megahertz you get serious issues of harmonics and interference at higher frequencies, so you don't do that. I need to check whether it's even good at filtering as it is. I'm still working the bugs out. I got sidetracked there. Now, this chip can have its output frequency changed, phase coherently. At a high enough rate, you can actually send FM modulated audio on it. I've done that. I can send a good quality voice through that method. It can also be used to send frequency shift keying data, and that's exactly what I'm doing here. I have the Arduino, the synthesis chip, my simulated radio link, and a receiver, RTO SDR stick. Now currently it's just sending an empty carrier, which you can hear there. If I just detune it a little, there's the signal. That is about 30 decibels above the noise floor. So that's a strong signal. It's not unbelievably strong, but that's a good day on HF. And these little spurious things here, I'm working the bugs out. And as I'm demodulating a pure carrier using upper sideband, of course you get a steady tone from it. Now this is what it can do. I'm going to send the mini modem man page to the Arduino serial port. Why is that not working? No, that's the listening side. Okay, mini modem running, send man page to serial port. And you get, oh, yeah, I know what's causing that. It's a problem with the receiving software. There we go. Just have to retune it, start it. There we go. And now it comes through without all those errors. That is 1200 BPS. Normally on an HF band, this is actually tuned to CB for testing, it's pretty close. On an HF band you would expect 300 BPS max. This does 1200 with a good signal. It will do 600 with a much more reasonable signal. And you can lower this thing down as far as you want. You can put this thing down to 60 BPS if you wanted, and it'll get through pretty much anything. I'm going to stop that now because the sound is annoying. Go. So it's a compact transmitter. It can do FM audio and it can do frequency shift keying. It's software adjustable for whatever frequencies you want. I've got it set to use bell tones. Simple, effective, dependable. All it needs is the output stage and maybe a bit of filtering and another radio modem. I think it's a good design. There's no messing around with intermediate frequency and mixing. It's just straight out the synthesis, RF, ready to go. It's a good design.